this presentation is the program of soil retention elements. We will start with the embedded retaining walls. So the process that we will follow for the presentation of this program is the same that we have already followed with the box culverts. We will go to the menu of examples. We will open an example. These examples are installed by default with the program, and we will see the workspace and so interesting menus. After that, we will define a project from zero using the assistant. So here we have the workspace of the program. We have also the different menus. The program permit to the user define different phases of the life of the element. In this case, we have this embedded retaining wall. The different phases are here. We can see the list of these different phases. We can start with the first of these phases. This is the retirement of this part of the soil. The next one is the application of this support. Next phase is the excavation to the necessary level to obtain the underground, and next one is the mise en place of this slab. Next floor, next underground, and first floor for our building. And finally, la mise en service. We start with this. We erase the support, and finally, we start with the service of the building. We have the surcharge of the depth load and the live load too. So we have here the important menu, always talking about the codes. We have the drop down menu with the different codes available on in the program. We have also the units, and we can go to the different menus in order to see the parameters that the user can modify. For example, here it's interesting to know that with this program we can obtain different type of embedded retaining walls. So we can define, for example, the reinforced concrete summary wall. We can also obtain a model with piles, micro piles or mini piles. We can also obtain the metal sheet piles. So all these type of walls we can model with the program. It's interesting to know that in this case the supports, for example, are model like that, defining this introductory phase, the final phase, the position of the elevation, axial rigidity, angle, etc. And we can also obtain the other kind of elements, like in support elements. We can define a new active anchor, a passive anchor. We can define also a new floor slab or a new strut. So we will define a project for a new project using also the assistant. For example, here we will use for this purpose the reinforced concrete slurry wall for buildings with 1 or 2 basements. So we can accept, and we will use the assistant and the drawings in order to know what parameters we can modify. So we have the clear height of upper basement, the clear height of lower basement, the transverse span, and the building is supported on the wall. For example, we can, for example, here define the number of floors above the ground level. We can also define the foundation type. We can isolate it or apply a mat foundation or isolate it without connection to the wall. All these parameters will modify after that the state of the element, the structure. So we can pass to the next menu. We can, for example, define here the some characteristics that will modify the overall the charge, the loads. So we have no adjacent buildings. We can also apply a road with light traffic, road with heavy traffic, or an adjacent building. In this case, we need to introduce the total number of floors and the depth of the foundation floor. We can pass to the next one, and we have here the soils. And we have type of upper soil layer with a drop-down menu with different type of soils. We have for example, we can modify and apply some other layers. Remember that once and that the initial features of the initial project is defined, the user can modify all that. We will finish the use of the assistant and accept the introduced data. So we can see here the different phases that the program have already defined. So we have the main structure. We have the excavation to the level 2.6. We applied a support, a strap, excavation to the necessary level for the second floor underground. First floor, and the service of the building with the different charge and the different loads. So now remember that we can modify or choose other, for example, code. We can also modify the type of the element. We have also the materials, have the concrete, the steel grade, and the exposure class. The loads and the coefficients to apply to the analysis and design. And now the general data, for example, for the soil. And we can, for example, edit a layer or a field. And now is the time for the user to modify these parameters in order to adapt these parameters to the geotechnical test. We can, for example, edit or apply different parameters to the initial support elements. Or we can define, for example, other phases, modify the loads, and we can also, remember, add the loads not only in the position of the, for example, the slabs or in the head of the element, but also add some of these loads in the point of the elevation that we need. That we can see that we can apply loads in different point of the elevation. It's important to know that we have a very interesting tool in order to verify in the center of the critical sliding circle. The program will develop a cloud of different points, analyzing and obtaining the safety factor for every point of this cloud, and will show the worst or the lower safety factor for the structure. We can obtain the analysis and design. We will go to the menu. The program will analyze and obtain the forces for every phase defined for the structure, and we will obtain the envelope of these different phases. We can check, for example, for every phase, the displacement, axial forces, shear, bending moment, earth pressure, or hydrostatic pressure too. For example, here we can see the shear for the different phases. And if we want to obtain the different phases superposed, we can go to this menu for obtain the different values for the displacement, the axial forces, the shear forces, or the bending moment. For example, here we will see on this sheet the bending moment for the different phases. So we will check or fill the different phases, and we can see the evolution of the forces of bending moment for every phase of the structure. Finally, we can pass to the sheet reinforcement, and we can edit in the same way that we have already seen for the box culvers. We can edit the diameter of the bars, for example, and the spacing of these bars, for every position of the reinforcement. And we can obtain a check after the addition. If we want to obtain the checks, we have this report that we can obtain in different formats: PDF, docx, HTML, etc. So we can also obtain from the printer the complete report for our project. And this is the complete report for our structure. We have the description of every phase. We have the description of the loads and the support elements. And we have also the result of every phase for the different points that we discretize the structure. With the elevation, we will obtain the displacement, the axial force, shear force, bending moment, earth pressure, and hydrostatic pressure too. Finally, we will obtain also, and very important, the quantities with the description of the reinforced bars in meters and in weight, and also the volume of necessary concrete for our structure. Talking about the drawings, we can go to the plotter and we can obtain the necessary drawings for this project. We can modify, for example, the scale. We can add or remove information here. We can also add some details. We have a library with general details. The user can add these details in order to enrich his project. For example, I will add this detail to my drawings. I will accept, I will also add, for example, a title block. The user can define also different type of title blocks, can accept, and we will see a preview of all this information. So remember, we have the block title, we have the information about the structure, we have here the detail that we add for our plan, and here the reinforced concrete slurry wall with the shape of the different reinforced bars, the weight, and the loss of 10% that we take into account. This value could modify by the user, and we will print all, and I will show you all this information in a CAD software. You can see, so the detail, this is a general detail. The user can modify the different text in order to adapt the values and information to his project. We have the reinforced details for the walls and the shape. Reinforced concrete, slurry wall, shapes and forms for the bars. So this is the presentation of the embedded retaining walls.